Greetings, coders. In this video, we're going to talk about why you might want to use a functional programming language. Basically, we talked about all these features in the last video, describing the benefits and we'll describing functional languages and the aspects of those languages. But what's so great about all those characteristics that we talked about? Why would you want to use a functional programming paradigm language, or why would anybody? So one of the reasons that is often cited is it's this shift away from how we do it to the what we want to do. So we replace these mundane low-level details that don't necessarily help you solve a particular problem, but are necessary if you're using a lower level programming language. And the functional languages are trying to achieve this level of abstraction that's similar and more like math. Certain things just happen automatically. You don't have to worry about it. You don't have to worry about what platform it's executing on, etc. And the idea is to create this large scale and reliable code. A reliable code. It offers statelessness, so you don't have to worry about all these additional variables tracking state. It has probably one of the strongest arguments is the concurrency support because it's stateless and because the functions don't have side effects. It makes it much easier to develop applications that need to run in these highly parallelized environments. So that's no outside influences on function execution. It creates safer and more predictable code because you don't have to worry about some setting off in three functions away that is changing this other function. As a result, the tests are easier to create and they're often more effective. So we end up with this elegant, reliable, perfect world where you have input, function, and then output. So you're ready to solve problems without even really programming. And that's a functional language. So what are some examples of functional languages? JavaScript has strong support for functional programming. It also supports imperative and object-oriented paradigms. Haskell is a pure functional language that embodies the principles of functional programming. And Clojure is a modern functional programming language that runs on in a JVM. And then we also have Lisp, Scheme, and Racket that are all very similar functional programming languages that use the X expression. And we in this class will be covering Scheme. So Scheme is a dialect of Lisp, and it is a most would call purely functional language. It uses the S expression notation, which is just going to be honest, it's just going to be a nightmare getting used to it. It's very different than what you're used to with other languages. No more braces. It's very parentheses focused. And elements are written as lists enclosed in parentheses. So you end up with something that looks like this. So what are the downsides? The biggest one, at least with the Scheme and Lisp based languages, is it's not pretty. I find it hard to read. It has all new syntax, keywords, and concepts that we haven't seen before, but we will cover. And it's heavily recursion oriented, which typically makes it more difficult to debug. So you end up with something like this. And that's it for this video.